Hello everybody, this is the first online SPSS lab that we're going to be doing. It's for an independent t-test. And basically what we're going to be doing for the SPSS labs is, of course, I'm not going to expect you to run SPSS. That would be silly, I think. What I'm going to do is I'm going to show you how the analysis are done in SPSS. And I'm going to produce some output that you're going to interpret. And essentially the labs will ask you those two things. One is I want you to outline the steps that show you how to do the different analyses. So it will just say outline the steps. So I want you to know how you can approach these things. But the big thing of the lab will be looking at some output and interpreting the output. And so what I'll say is that I will also show in the videos about how to look at the output and to find the numbers that you need for the labs. So this first lab is independent t-test. So remember, with independent t-test, we have two different groups, two separate groups between subjects design, and we're comparing them on some sort of DV that is at least approximating interval level, meaning that there's numbers that we can do some mathematical operations with. So this first part, I'm going to just show you how to conduct it with some data, and I will show you some output and how to interpret the output. And so for this one, for independent t-test, and the menu looks a little bit different. I think they made some revisions to this, but always pretty much go to analyze, compare means. Remember the independent t-test, we're comparing two means of two different groups. Analyze, compare means, choose independent sample t-test. Again, in the labs, I'm going to ask you to outline these steps. You don't need to say too much. I have at least a bullet description of the main steps. So there's two different things that you need to put into the little boxes here. So the one I usually start with is the grouping variable. Grouping variable is identifying the two groups that you have in your independent t-test. So I'm going to go down to the bottom here. I created a variable from an old class that identified people as psychology majors or not psychology majors. So I called it psych or not. A tricky thing about independent t-test is it asks you to define the groups. All this is doing is it's having us tell the values, and so I gave 1 to people if they were a psych major. I gave 0 if they were not a psych major. And what this is actually asking us to do is it's asking us what order we want the means in. And what SPSS does, SPSS will take group number 1 minus group number 2. So I'm going to just have psychology majors be the first group, and we're going to subtract the mean of not psychology majors on the dependent variable. So we have to do this. This is very important to remember in independent t-test, is that we have to put values in here. And again, it's going to take 1 minus 2, but we have to give values to it. So I put 1 for psych majors and 0 for not psych majors. So it's going to take the psych majors mean minus the not psych majors mean. Press continue. And the test variable is simply the dependent variable that we're comparing those two groups on. And what I'm going to do is I'm going to see if people exercise. So this question asks, how many times in the last 7 days have you done vigorous exercise for, I think, at least 30 minutes? And beyond this complication of defining your groups, it's pretty simple. So once we define our groups, we select our DV and we press OK. So here's the output. So in the output, you can see that, and I'm counting that you can kind of see this. I think I'm going to actually clip it, so I'm not so worried that you can't see it. Just give me a second. At least by clipping it, I can make it bigger. So I've just clipped the output. I don't know if I can move this. Well, that's kind of cool. I didn't know I could do that in that. Sorry, I had no idea that it would do something like this. It's kind of cool. Let me snip it again. Actually, I might use that as a teaching tool. Sometimes you make mistakes and it turns out to be a good mistake. It looks like I could even save it if I want to with those lines. That's kind of cool. So I'm going to just make it very messy if I do it, but let's see. It looks like I have lines. I'm gonna test it out over here. I have to click it to kind of. Oh, that's kind of cool. So I'm going to use this. It's going to get a little bit messy, but I think it's okay. So here you can see it's actually listing the DV. So that's the DV. So it's saying in the last 7 days, how much have you exercised, blah, blah. It's going to give the groups. So here's the two groups. So one was psychology. So you have to remember that. So psychology is 1. 0 is not psychology. And it's going to give the sample size for each group. That's at n, by the way. So there's 16 psych majors, 23 not psych majors. It's going to give the mean. So here's the psych majors mean, it's 2.13. And here's the not psych majors mean, 4.04. So at least in terms of the means, the psych majors are getting a lot less exercise than the not psych majors. It gives the standard deviations for the two groups, 1.8 for psych majors, 3.18 for not psych majors. And of course, we need this for the write-up. And then there's the standard error of the mean. This one we don't have to worry about so much in terms of writing up your findings. So when you write up your findings, you of course need to say what's the mean and standard deviations for the two groups. So psych majors mean standard deviation, not psych majors mean standard deviation. You aren't going to do the psych major stuff for your output. I'm going to give you a clean output for another study, but you will have to locate these things. And then, so that's the descriptive statistics. And so I want to look at the t-test, obviously. And what I'm going to say is we're going to not worry so much about this. There is, remember, homogeneity of variance is a assumption of a t-test. And in this case, we violated that assumption. But what I'm going to say is let's just pretend it's not violated. And we're just going to pretend that there's equal variances, which is actually in the study that you're going to look at. The test for homogeneity of variance comes out to be good in the sense that there's similar variances across the groups. This one, not so good, but let's just pretend, because in the study that I'm going to give you output for, we want to assume equal variances. So there's two lines here, equal variances, not equal variances. Stick to this line right here. So here we have a t-test. So the t is negative 2.17 in this case. Why is it negative? Because we took the mean for the psych majors, which was 2.13, and subtracted 4.04. So since they had less exercise, it comes out to be a negative t-test in this case. We have the degrees of freedom, and we have the significance. So significance tells us the probability of a type 1 error. So this significance test right here is the probability of a type 1. If I can draw it right. Type type 1 error. So remember, for us, we've always set our alpha at 0.05, which says that we don't want to make a type 1 error with a probability of greater than 5%. So when we're looking at these, we're going to be looking for a 0.05 and below. However, there's a little bit of a trick here. I don't know if you can see this, and I will zoom it a little bit, I think. I'm going to zoom this a little bit, and you can see that it says two-tailed. So if it's two-tailed, we have a problem because we want to make one-tailed predictions, because we're making a prediction that is going to be higher or lower. So given that, what you have to do is you have to not do what I just did. But if it's a two-tail, you have to divide it by 2 to get the one tail. It's a cool tool, but it takes a little bit to... So SPSS again gives you the two-tailed probability, but because we have one-tailed predictions, take this number and divide it by 2. So our actual significance here is 0.018, it looks like. So 0.018 is less than 0.05, so we reject the HO. Because what it's telling us is that we have only a 1.8% chance of making a type 1, and that's lower than the 5%, which we say we can live with. So if the sig, and we're talking about the one-tailed sig in this case, is less than 0.05, we reject the HO. And watch this. We reject the HO. I was trying to use that 0 here. So we reject the HO. Why? Because in this case, it says that we only have a 1.8% chance of making a type 1 error, which is less than 5% chance that we say is acceptable. And vice versa. So if we get a sig that is greater than 0.05, it's telling us that we have a greater than 5% chance of making a type 1 error, and so then we fail to reject the HO. Let me sort of refocus this thing here. So that's all. That's much of the information that you need. There's one other piece of information you need, and this is that we have the 95% confidence interval. So we have the upper part of it, and we have the lower part of it right here. So this is all the stuff that you need. So if I were to interpret this, because remember, it's significant, so there is a difference, I would say that psychology, this one right here, psychology majors mean, so psychology majors parentheses mean equals 2.13, comma, standard deviation equals 1.82, parentheses, end of parentheses, got less exercise than not psych majors, parentheses, mean equals 4.04, comma, standard deviation equals 3.18, end of parentheses, comma, t equals negative 0.217. I'm sorry, I should say t, parentheses, 37 degrees of freedom, parentheses, t parentheses 37 equals negative 0.217, comma, p is less than 0.05, period. Don't have to do effect size here. We don't have effect size. Next sentence, the 95 CI, which is right here, 95 CI was brackets negative 3.71, comma, negative 1.3, end of brackets, period. So I know I've marked out a lot of things, but I think it's helped you see things. So just in that output right there, we see that we got the mean standard deviation for each of the two groups right here. So that's your descriptive information. The t is here. The significance is here. We have to divide it by 2. Our degrees of freedom are here. So we know it's significant. And we can look at the means, even if we're confused by whether it's positive or negative t, it doesn't really matter. Just look at the means. The psych major's means is less than the not psych major's mean. So basically that's it. That's how you interpret the output. And you simply are going to, for your lab, is to write up the findings of another output in terms of interpreting whether there's a significant t or not. There's actually 3 t-tests in the ones I'm going to do for you. So that's an example. I'm going to actually run the other one. So for this, these are actually data that was given. I was quite surprised. It's actually a published study. It's a published study in a pretty solid journal, not even a solid journal, I think one of the top journals. And they allowed their data to be used for educational purposes. And so in this study, what they did is they were curious about whether you make a better impression if somebody read a transcript of you describing yourself, so in writing, versus an oral or an audio, without seeing somebody's face, just basically listening to an audio description of yourself. So they did those 2 conditions. So basically they had people who were actually in business and they were in charge of hiring people. And so for half the people, they read a transcript and then rated the candidate on several things, and then the other half of people had the audio version. And so if you can see this, under condition, which is the variable, they had 1 as the audio condition and 2 as the transcript condition. So this is a job candidate describing themselves. So do you hear or you're reading a transcript of it? And it's between subjects, it's independent t-test, so half of the recruiters, people who hire people, heard the audio and the other half just read a transcript. And what was said is the same. So the transcript and the audio were the exact same words. And what they did is they had the recruiter rate 3 things. I don't know if you can see this, it doesn't really matter. I'm going to actually pull it, it's a label here. So they had them rate 3 things. So the candidates were rated on their intellect. So that's 1 dependent variable. The candidates were rated on the overall impression that they gave, the recruiter. And they also rated them on how likely they would hire the candidate. So there's actually 3 dependent variables here. And actually, I'm going to run 3 different t-tests, independent t-tests, to test these. And I'm going to have you interpret each of those tests. And so again, the condition was the recruiter either heard an audio recording of the job candidate describing themselves, or they read a transcript. So those are the 2 groups, and the dependent variables were rating the person's intellect, rating the person's overall impression of them, and rating how likely they were to hire the person. I'm going to run these 3 t-tests all together. So remember, analyze, compare means. Independent samples t-test. So remember, the tricky thing is this grouping. So condition is the group. So we want 1 minus 2. So the idea of the researchers was that the audio condition would lead to higher ratings versus the transcript condition. So we're going to have 1 is the audio minus transcript, which is 0. So we're looking for positive t-test here because we think that the audio condition, 1, is greater than the transcript condition, which is 0 in their coding system. And I'm going to put all of the dependent variables in all together in the test variables. So the ratings of the person's intellect, the overall impression that the recruiter had of the person, and how likely they were to hire the person. We just press OK then. And it's probably behind here somewhere, and it is. And so this is the output. And I've actually saved the output, and it will be on SPSS. I'm going to open up that output. So we'll just say lab 3 SPSS output on Canvas. And here's the output. So you should interpret this based on what we had talked about with the other output. I'm just going to highlight that there's 3 independent t-tests. So this one, this thing is about intellect. We have the means and standard deviations of the 2 groups here. We have the descriptives for overall impressions, mean, standard deviation. And then we have hiring, mean, standard deviation. So we're going to run, those are 3 different t-tests. So you need to write 3 different results sentences based on those 3 different t-tests. The t-test information for intellect is here. T-test information for overall impressions is here. And the t-test information for hiring, likelihood of hiring, is here. So just make sure you know that these are 3 different t-tests, and you can see that there's 1, 2, 3. Remember to look at equal variances only. So equal variances, this is the intellect. Look at this line for your information. Overall impression, look at this line for your information, equal variances. And likelihood of hiring the person, equal variances. And by the way, these tests are for equal variances. If they are greater than 0.05, then they're equal. So look at this line, and this line. Again, there's 3 different t-tests that you have to interpret. I hope that is clear, and I hope this video was helpful. And again, as announced on Canvas, if you have questions, we do have live sessions 4 times a week where you can ask questions. Okay, see you later.